Okay, my name is Jeff Varney. I'm the regional sales engineer for ClaVal, and I cover Riverside County, San Bernardino County, Kern County, and the Antelope Valley. And we're here today to just review operation and also principle of operation, and also just some maintenance points for the two valves installed here. We have a 90 series, a 90-01 pressure reducing valve we're going to cover, and then also the 50-01 pressure relief valve as well. We want to start off just briefly just looking at what completes a typical complete automatic control valve. We have the modified globe design, and these are just the four basic design features here. It's diaphragm actuated. So this red element here, this is the red elastomeric diaphragm that separates the control chamber on top from the rest of the system fluid flowing through the valve. It's hydraulically operated, meaning that it does need some sort of hydraulic pressure source to be able to operate the valve, to have it open or close. And so typically we get that from the upstream body port here, and but we could also use an independent source of pressure to operate the valve. And so the water pressure is the energy source to make this valve move open and closed, in other words. And so we do need some sort of hydraulic pressure to do that. And last is pilot controlled, and so we can see that with the pilot controls we have on the Hytrol main valve completes an automatic control valve. Without the proper components, tubings and fittings in their proper order, we have just a very stupid main valve, a very dumb main valve, and it's just a slave basically of what the controls that we put on it tell it to do. And so that kind of completes the automatic control valve and why we need it. There we go. And a couple graphics here just to show us how the valve operates. It does take line pressure to open the main valve. You can see here we have a cutaway of a Hytrol. On the gauge we see 100 psi. In the cover chamber here we have this vented atmosphere right on the top of the cover. And you can see without any pressure in the cover chamber, you can see that our 100 psi coming in will push open the diaphragm assembly, and the water now is able to flow up and over the seat. And if we look at our formula here, we have 100 psi right here coming in times 6 square inches, and that's the seat area in the Hytrol main valve. That gives us 600 pounds of force now. It's pushing up underneath the diaphragm, because essentially we have 0 in the cover chamber. And so now we have 600 pounds pushing up on the diaphragm assembly, and you can see the water is going up and over the seat. The other side of the coin is it takes line pressure to close the main valve. So now what we've done is rather than have our cover vented atmosphere, we have plugged our cover chamber now, and we're connecting it to our upstream body port here. And so we still have 100 psi coming in. So now essentially we are going to introduce our 100 psi into the cover chamber. And so when we do that, when we equalize pressure on the upstream side as well as in the cover chamber, the main valve is driven closed. And again, we can see doing the math here, we have 100 psi coming in. We have now, rather than 6 square inches here, we have actually 10 square inches on top of the diaphragm. And so that gives us, if we do the math, 1,000 pounds of force now pushing down on the diaphragm. And so we do have 600 pounds still pushing up, but that gives us a difference of 400 pounds of force now pushing that valve to the closed position. And so essentially that's the principle of operation of how the Hytrol works. Very simple animation here to flesh it out, and basically it's our mitral main valve in the line here, and we have, of course, water flowing through it. We have, as our control mechanism, a very simple three-way pilot control valve. Now, this could be a three-way ball valve. It could be a three-way solenoid valve. It could be one of our components. It's a three-way component. But any component that has a common connection going into the cover, so we're blocking supply, venting covered atmosphere, or to the low pressure, the downstream side, opens the main valve. But when we block the drain and introduce upstream pressure into the cover chamber, we are going to close the main valve. Pretty simple. Now, this is a non-modulating valve. The valves that we have here are modulating valves, and we'll see their operation in just a few slides. Real important information on the basic main valve, the mitral. There is a ID tag that is riveted to the inlet, top of the inlet flange, and it tells us inlet in 4 different languages, and that English, German, French, and Spanish. Also, it tells us the size and catalog number on this top number that's stamped into the nameplate. And if you're talking to me or somebody at ClaVal, that's a good number to use in referencing the valve and what you have if you're trying to troubleshoot the valve or order parts for it or that type of thing. The number below that is a stock number. That's a number that tells us every detail about that valve, when it was built. It tells us the materials used, the coatings, of course the type of schematic that it's built from, and then also a date code here. It tells us what month and year the valve was manufactured. 2.5 inch and larger, it's on top of the inlet flange. 2 inch and smaller, it's on the side of the body. And this is just looking at the disc diaphragm assembly. And this is the single moving part in the valve. The diaphragm seals the line pressure against the, as opposed to the cover pressure on top. And this is just detailing the operation of the isolation ball valves. There's one on the upstream side, there's one on the downstream side of the pilot system, and also there's one on the cover chamber. Now, if you need to emergency close the valve, or if you're planning to do some maintenance on the valve, very simply, if you can afford to shut off flow from to the downstream, very simple, just close this downstream ball valve 90 degrees, and what that does is it forces water onto the cover chamber to close the main valve, just like we saw in that animation, and that drives the main valve to the closed position. Also, if you're looking to possibly check the Y strainer, just to do some maintenance on the pilot controls, you can close the downstream, close the cover connection, and then also the upstream ball valve. And then that allows you to access the Y strainer, also to rebuild or service any of the other components without having to close the isolation valves in the line here. So you can leave both these isolation valves open while you're doing service on the controls. Okay, one of our valves here, of course, is the 90 series or 90-01 pressure reducing valve. And we're going to get into a little bit of the principle of operation for that valve. The pressure reducing valve, it's designed to make sure that we have a maximum pressure downstream, regardless of the upstream pressure or the flow rate. So regardless of the upstream pressure flow rate, it's always looking at the downstream side. It's always making sure it's at a maximum pressure at all times. And it's protecting the downstream side is what it's doing. And that's its job. Just taking a look at the pilot control system. Of course, the inlet side is the high pressure coming into the valve. The downstream or outlet of the valve is the lower pressure side. We can see the pilot controls on the mitral main valve here. First we have, of course, the isolation ball valves, and next we'll have a orifice restriction, a cover connection going to the cover of the main valve and then also to the pilot control. We call this a CRD, which means control reduce is what CRD means. And it is basically the brain of the main valve. It tells the main valve when to open, when to close, and so the CRD pilot is the brain. Our first component here after the upstream ball valve is a Y strainer. This is a very typical Y strainer where you have high pressure, unstrained water comes in through the left side here. It has to come through the screen before it exits out the other side. A couple points obviously is the servicing of the screen. It should be checked at least a couple times a year, depending of course on the water quality and how much debris as it is anticipated. And the best way to do that, rather than put a ball valve on the end, is basically just to isolate the pilot controls with the ball valves, and then pull this plug out so you can check the screen and put an eyeball on it, make sure that it's free and clear. Next is the X58. This is a very simple orifice restriction, and it's installed right inside these 3/8 inch half union, half flare, half pipe fitting connection fittings here. And there are two sizes basically. There's the red, which contains an 1/8 inch orifice, and this is good for 4-inch main valves all the way up to 16-inch main valves. And typically you'll see that 1/8 inch orifice restriction there. The ones that have a blue dye coating on the outside, these are typically 3/32 orifice sizes, and these are for 3-inch and smaller main valves. And the trick behind the orifice restriction is that it enables that main valve to open when the CRD pilot opens. And so it causes a pressure drop to occur in the cover chamber and gets that main valve open and flowing. This is the CRD pressure reducing pilot control. It is normally open. It closes on a rise in downstream pressure. That's where we're sensing. And of course it senses pressure through one of these two outlet ports right here. These are common ports, and one is typically plugged. You can use that for a gauge port if you don't have any other ports downstream of that main valve available. And you can see on top here we have the of course the cap. We have the adjustment screw that once you remove the cap, it allows you to adjust the downstream pressure. And if you put a 3/8 inch hex nut driver or wrench clockwise, will increase the spring tension, and what that does is it increases the downstream pressure at the same time. So basically you're saying that I need more hydraulic pressure to push up against this diaphragm here to push this disc and disc retainer assembly right against the seat to close the control component. And the pilot has the standard springs of 30 to 300 psi range spring, and I believe that's the one that we have here. And it does need to be serviced. The service points are parts are the diaphragm here, also the noted the disc and diaphragm, the retainer assembly here.
Question: if you were to take that pipe apart, does the spring have a color? Are they rated?
Yeah. Yes, they do. The 30 to 300 is a green spring, and there's another range that's fairly common. It's the 15 to 75 psi, and that's the red colored spring.
All right, thank you.
And CRD, I think I mentioned this earlier, control reduce. So this is a reducing pilot. In fact, the CRD is a very common pressure reducing pilot. It is basically a smaller version of say, a house regulator that you would see on homes. And it's a modulating control pilot. And this graphic here gives us the three different positions, or relatively three different positions. It could be in any one of these. It could be, you can see it's wide open. You can see that when water comes through our inlet port, down through the nozzle, across the seat, you can see this allows the pilot to go open. It could be partially open. You can see that there's just a hair off the seat, and it's ready to go closed. Or it could be in the fully closed position. You can see here that now the disc retainer assembly is fully against the stainless steel seat, and the pilot control is now fully closed. So it is a modulating pilot. Okay, we have now three of our essential components right here. And typically this is how it looks when it's built on the valve, when it's all piped up. We have our X58 restrictor here, our orifice restriction. We have our cover connection. This, of course, one is going to the pilot, one is going to the cover. And then we have our modulating control pilot, our CRD pilot. And it's detailing its quarter-inch orifice through going through the seat down to down into the pilot body. And so it's important to realize that this restrictor here is smaller than our orifice size in our pilot here. And we'll see why that's necessary. Okay, any type of modulating hydraulic pilot with a flowing pilot system is going to have these three significant essential components. Of course, the first one is the restrictor, the other is a cover connection, and the third is some sort of a modulating control pilot. And in this case, we're using the CRD pilot. For the 50 series, we use a CRL modulating control pilot. All right, we have a couple slides here that will demonstrate how the valve operates. This is showing the main valve is in the closed position. And why is that? Well, let's go through all the pressures we have here labeled. Upstream pressure, we're still looking at 100 psi. Now this could go all the way up to, if our valve has 150-pound class flanges, we could go all the way up to 250 psi. And so this pressure will vary. Let's see, downstream we have 68 psi currently. And so basically what's happening is our CRD pilot control, currently it's set at 65 psi in the spring. And we know that because somewhere downstream we have a pressure gauge. We have a gauge basically to tell us what's going on in the system downstream. So we have to have some sort of a pressure gauge that's accurate, telling us what our pressure is in the system downstream. And so currently pilot is set at 65. In pressure downstream in the line we have 68. Who's going to win, 68 psi or 65? I think 68 psi is going to win, right? And so what's going to happen is our 68 psi is now going to be transferred to our pilot via the 3/8" piping, and so that's going to make its way right underneath the diaphragm here. And our spring is still set at 65, and so what's going to happen, our 68 psi is going to overcome now our mechanical spring tension, and you can see it's going to push this disc retainer right up against the seat. Okay, and so now pilot control is closed. We still have a flowing pilot system until that happened though, and so when our pilot control closed, guess what? pressure now goes through our cover connection and fills our cover chamber. And so as it sits right now, we have 100 psi here, and that is being transferred through orifice restriction into their cover connection, and we're equalized. So we got 100 psi coming in, 100 psi in our cover chamber, just like the animation we saw when we equalized the two areas. The main valve is in the closed position, or is going closed. And if there's if we're trying to troubleshoot the valve and that's not happening, a couple things we need to consider. There may be maybe a pile of rocks underneath the main valve stem that prevents it from traveling to the fully closed position. There may be a problem with our pilot control. But this is our 90 series pressure reducing valve in the closed position, or the main valve is opening. Well, what changed? Inlet pressure is about the same, about 100 psi. That really doesn't change too much. What changes our downstream pressure. Now, typically when our downstream pressure drops, we have an increase in demand in the system. So we've had irrigation come on, or valves in the system come on, and so that precipitates a drop in downstream pressure. So again, that pressure is now it's transferred through the piping to the pilot body and right underneath the diaphragm. And so again, if we have 60 psi, our spring in the pilot doesn't change unless you physically go there and manually change the setting on the pilot. That doesn't change. That's still set at 65. This is going to now start creating a change here. And so who's greater, 65 or 60? Well, now the 65 psi is greater, and so now our mechanical spring here is going to force open, overcome now the hydraulic pressure that's in our system, and now our pilot is going to start to open. And when our pilot starts to open, and you have to remember we have our orifice restriction here, our 1/8" orifice restriction, what's going to happen is we're going to actually flow more water off the cover faster than it's coming on to the cover chamber. And so now our pilot opens up with our 1/4" opening here. We're going to start moving more water off the cover chamber. Now when that happens, we also create a drop in pressure now in the cover chamber, because now we're taking more water off the cover than what we're able to supply on through this much smaller 1/8" orifice fitting. And again, we could have a pressure drop from say 85 maybe up to 97 psi. And so what's going to happen if we have a lower pressure in our cover chamber? We still have our 100 psi here. So who's going to win, 100 psi or say 85 psi? Well, I think our 100 psi is going to overcome the lesser pressure in the cover chamber. It's going to push that assembly up, and that's going to start creating some flow through the valve. And we have some animation to flesh that out for us here. So here's our 90-01 pressure reducing valve, and we are setting our pilot regulator now for a maximum pressure of 50 psi in the system. And of course we can tell that because we have our gauge downstream. It tells us our pressure. And so you can see it's keeping a maximum pressure all the way through the different flow ranges, through the different demands in the system. It is keeping a maximum pressure of 50 psi in the line. You can see flow started dropping. Demand started dropping, and you can see that precipitated a change in pilot position. And that's what the pilot will do. It will make small changes throughout throughout the day, and keep a maximum pressure of 50 psi in the system, or whatever pressure you adjust it to. This is just a close-up version of what's happening in our control system here. Again, we have our high upstream pressure coming through our orifice restriction, the cover connection, going to the main valve, and then through the pilot. And of course, Here's a gauge downstream. You can see it's keeping a maximum pressure of 75 psi downstream. Now it's modulating, and you can see the yoke assembly and the diaphragm working. And whenever it adjusts, that means there's a change in pressure in the downstream side. That's the only time really it makes adjustments in its position. And as the pilot starts going closed, well, we start backing up a little bit more pressure here in the cover chamber, and the main valve starts going closed. When you can see this orifice size through the pilot starts to open up, well, then we start taking more cover chamber water off the chamber here, and the main valve starts opening. This is the CRV pilot, and we'll just take a few slides to see how to adjust it. The green spring is the 30 to 300. This is the default spring, so if you don't tell us ahead of time what you want, you will get the 30 to 300 psi range spring. 15 to 75 is a red painted spring. We do have a what's called a 2 to 30 range spring. It's actually just a stainless steel spring. And then also a CRD 18, which is a little bit higher pressure. Adjusting the pressure reducing valve, some flow is required. That's the way I like to set the valve. We can create just a small bit of demand to create a pressure drop on the downstream side. It doesn't have to be much, just enough to get some water flowing through the valve. That's the best way to set the pilot. Clockwise to increase the downstream pressure, counterclockwise to decrease downstream pressure, and of course when you go counterclockwise, you're decreasing the tension on the spring as well. Make all the adjustments slow and allow the valve time to respond. And of course, when you're doing this, watch your downstream pressure gauge. If you have a position indicator on the valve, that's also a good tool as well. Okay, any questions on pressure reducing? All right, let's get over to pressure relief. The pressure relief valve is designed to open rapidly when that inlet pressure rises above the pilot setting, and then start closing slowly when that system pressure drops below the setting on the pilot. And this is the 50-01 model. Here's a graphic of where our pressure relief valve would be used in the system. This is installed on the system side downstream of a booster pump, and it is sensing upstream pressure. It doesn't care about what's going on downstream, and just like the pressure reducing valve, it doesn't care about the flow rate either. And so its job is to monitor upstream system pressure, making sure it doesn't get too high. And it's protecting the system at all times. Let's go ahead and go through the pilot system quick. Again, it uses the same high-troll main valve. That doesn't change. Our first component after the upstream ball valves is the what we call an X42N2. It's a combination Y strainer needle valve, and it also has an extra port for a cover connection, and also a sense port for the pilot connection as well. But essentially, it's you can see here it's a Y strainer, and then once we're straining out all the heavy debris, it's also a just like on the 90 series, we have in this case, it's an adjustable needle valve to create that pressure drop to occur in the cover chamber when that modulating pilot opens. These are not set from the factory, and so these have to be custom set to the application. Looking at valve size, 2 to 3 inch. This is turns out from the seat, so in order to adjust this, I would loosen the jam nut, screw that needle all the way into the seat, and back it out 1/8 of a turn. It's not that much, but for a small valve, that's really where it needs to be. 4-inch main valve, it can be adjusted out maybe 1/4 of a turn. because we want this, we want the main valve to react quickly, but at the same time we want it to close slowly as well. And here's our pilot control. This is the CRL. This is a pressure relief pilot. It is it's normally closed. It opens on a rise in pressure, and you can see when we introduce upstream pressure underneath the diaphragm, basically what's going to happen, if it's greater than the spring tension on top, it will overcome the tension on the spring and then connect it down to a stem on a disc retainer. It'll lift up the disc retainer off the seat and get water flowing across the pilot here. And it does sense pressure remotely. We have to sense across the any type of restriction we have upstream. Also, we have to sense in front of any type of Y strainer or any component that's protecting the pilot system here. CRL means control relief. And so a little bit different. It's a relief pilot, so control relief is kind of what the acronym stands for. A couple slides here we'll go through real quick. Main valve is in the closed position. Well, why is that? Currently we have an upstream pressure of 100 psi, and that's of course where our pilot is sensing through our quarter-inch tubing here, through our supply tubing. It's sensing that upstream pressure constantly. Our spring here, though, is set at 115 psi, so now currently we have more tension on the spring than we do hydraulic pressure being introduced underneath the diaphragm. And so with a greater spring tension, we're pushing down, overcoming the hydraulic pressure, pushing that disc retainer right on the seat. So this valve, the pilot, the main valve is going to stay in the closed position until something changes here. This is showing our main valve is open. Basically what had happened is we had an increase in upstream pressure. That's where we're sensing, and so that upstream pressure transferred up through the tubing underneath the diaphragm here. 116, yeah, that's going to overcome our 115 psi, and that's going to open up our main valve. And so just like in the 90 series pilot control, once that modulating pilot is open, well, that means we're going to actually start taking more water off the cover chamber than what we're able to supply on. And remember, we have this adjustable needle valve that we can use to regulate, modulate how much water is coming from the upstream side into the cover chamber.
So it's like a speed control?
Technically, yeah, it's kind of like a closing speed control. Yeah. And so if you back this out, well, the valve is going to get a little bit more sluggish as far as opening, but probably a little bit more stable while it's flowing. And so in a pressure sustaining application, we would probably back this needle out just a little bit more so the valve would modulate a little bit more steady. The seat diameter is a 1/2 inch on the CRL pilot. Does anybody remember the CRD diameter, seat diameter? It was a 1/4 inch, so this is much greater of a open area. So we can pass a much greater volume through the pilot out of the control chamber here. And so, and basically that's what we want as far as a pressure relief valve. We want this thing to open quickly, but close slowly so we don't recreate another surge in the system.
That only work when you have a high pressure in the upstream?
That's correct, yes. Yeah, if it's greater than what we set on the spring, and again, we do that from having a pressure gauge on the upstream side. Yeah, so if that hydraulic pressure overcomes the tension in the spring, yes, the pilot opens up, and then of course the main valve is going to open up after that. All right, let's take a look at this animation. Currently we have our CRL pilot set at 60 psi. Now we're going to watch the upstream gauge here. System pressure goes above the set point of the pilot. Pilot opens up because now if the hydraulic pressure is overcoming the tension in the spring, And when our pilot opens up, main valve is going to open up because we have, you know, our adjustable needle here to create that pressure drop to occur in this zone right here. And when that happens, of course, our higher upstream pressure is going to push this diaphragm assembly up, and we're going to start flowing water. Okay, that's it. Our 8-inch 90-01 pressure reducing valve here. And the nameplate is on top of the inlet flange here. And if we need to get any more details on the valve. Okay, and again, the function of this valve is to limit the downstream pressure to a preset maximum that we have on the modulating pressure reducing pilot, and we call this the CRD pilot, of course. And basically we take high pressure from the upstream side, take it through our upstream body port through our Y strainer. This is a maintenance point. This should be checked and serviced a couple times a year.
Strainer?
The strainer, correct. Yeah. And then to our fixed orifice restriction, we call this an X58. And again, this has the 1/8 inch orifice inside. And our cover connection, which is basically our female T right here. On this valve here, we have the option of a opening speed control that has been added. And basically the opening speed control will regulate the amount of water coming into the side port here and out to the pilot when the pilot is open. And so when the pilot is open and we're taking water off the cover chamber, this needle here will regulate the amount of water flowing across the little needle and a disc inside here. This does not affect the closing speed of the valve. It only adjusts the opening speed when water is coming off the cover chamber through the pilot when the pilot is open. And up to the cover chamber, of course, we have our isolation ball valve. And brings us to our CRD pilot control. This is a 30 to 300 psi range. Currently it is set at 60 psi. So it's going to allow no more than 60 psi downstream. We have a 0 to 200 psi pressure gauge here to be able to set the pilot here. And again, setting the pilot is fairly easy. It's just a matter of removing the plastic cap on top, loosen the jam nut, and to increase pressure, take your 3/8 inch nut driver and increase clockwise the adjustment of the adjustment screw here. We're going to increase the pressure on the spring. If we want to decrease pressure, we'll take this out counterclockwise. Then reset your jam nut.
You do that in small increments?
Yes. For the 30 to 300 psi spring, it's about 28 psi per full turn.
28.
28, and it's about 7 psi per quarter turn.
And it's set at, you said it's set up for 65?
60 psi.
60 psi. So this is going to our hydro-pneumatic tank. Okay. So that's
the main valve should be serviced approximately every 3 to 5 years, along with the pilot controls. And of course, at the same time, we'll check the screen and the Y strainer. Check also the making sure that the fixed orifice restriction, this is still intact, and also the check the adjustment, and also the making sure that there's no lime, rust, calcium deposits in the opening speed control here. We call this a CV, and let's see, and I think that's it. Anytime service is done, after service is done, the valve is reassembled. We need to also loosen the top plug here, make sure all the air is bled out of the cover chamber. That's very important. And any questions?
said on this one, you can shut off all the ball valves to clean the strainer.
That is correct.
And the ball.
Yeah, if our line is open and we have pressure on the upstream side, it's a very simple matter of you close the downstream ball valve first.
No water coming in.
Right. Close the cover connection, close the upstream side. Now you've isolated the controls from the pilot, or excuse me, the main valve, without having to isolate the main valve upstream and downstream. And so now you can check your screen and your Y strainer. You can also service your pilot and check the other components as well. And then when you're finished, it's a matter of reversing the steps, upstream, cover, and then downstream when you put it back in service.
And if we don't want the valve to operate, we just close that discharge on the.
That is correct, yeah. If you want to shut the main valve off drip tight, very simple of just closing that 90 degrees. It's a lot easier than having to close a gate valve or butterfly. And you're going to get a drip tight seal as well.
It works. I have it done right now at well 13.
That's right.
We're bypassing it, but we're going to waste.
Any other questions? All right. All right, let's move over to our 50-01 series pressure relief valve. And again, all the information is on the stamped on this brass tag on top here. So if you're contacting ClaVal, all we need to reference is the size and catalog number, and that tells us exactly what model you have. The principle of operation for this valve is that it senses upstream pressure through our pilot here, through our X42N2, and it senses the upstream pressure. So it's normally closed, and it'll stay closed until the upstream pressure here is greater than the spring setting on our pilot. We have, just like with the 90 series on the downstream, we have a gauge on the upstream. The upstream gauge here tells us what the setting is on the pilot. This valve has a 20 to 200 psi spring range in the pilot here. It's actually the same green spring as we have in the CRD pilot. This valve also has a dual limit switch on top. So currently the valve is in the fully closed position. We have the adjustable brass collar here actuating the closed limit switch. When the valve opens, we have on top we have a open limit switch collar here that will actuate the open limit switch, and that gives the operator's indication of what position the valve is in. The adjustment on the needle here, this is pretty much set. It really doesn't have to be adjusted. It is set to about a quarter turn off the seat. And again, maintenance points are a couple times a year we need to pull the plug and just check the condition of the screen, making sure that it's free and clear of all debris.
And we do have enough room to pull that out right here?
Yes, you do. Yeah.
It's tight.
Yeah, it is tight, but now you have enough room to pull that plug in the screen. The screen and the X42N2, a maintenance item. And again, between every 3 and 5 years, the main valve, also the pilot, and should be serviced. New repair kits should be installed. And any questions? As we saw, this is sensing upstream pressure only. It doesn't care about the downstream pressure, and it doesn't care about the flow rate. It's only actuated upon a higher pressure than what we have set in the spring here. And again, if you want to readjust the pressure, It's a matter of taking off the black cap, loosening the jam nut. To increase your relief pressure, you want to go clockwise, increase the tension on the spring. To have it open at a lower upstream pressure, it's just a matter of counterclockwise and decreasing the tension on the spring. And again, the same goes with the operation of the ball valves. To manually close the ball valve, the main valve, close the downstream ball valve, and that'll drive the main valve to the closed position. Normally, you do not ever want to see this valve in the closed position. If the downstream ball valve is closed and we have a high pressure event on the upstream side, the main valve's not going to open. And so we always want to see our ball valves in the normally operating open position through the upstream, cover, and downstream. The air bleed on this particular valve is this round head machine screw. It's located on the hex of the adapter here. It's over on this side. And again, after every time the valve is serviced or water is bled out, here's our adjustment right here, we want to make sure that we open that up, make sure that we get water coming out, and make sure that all the air is bled out of the cover chamber.
There's an O-ring for that seal right here, isn't it?
Yes, there is. I'm glad you brought that up.
Very small. I mean, you don't want to tighten down at all, hardly.
Yeah, you don't. There's actually 2 O-rings in here. And no, I would not recommend opening this up to bleed the air out, and that's why they came up with drill and tapping through the adapter fitting here. And so I would just recommend every time you do maintenance the valve, I would recommend you changing out both these O-rings inside the limit switch here.
You have to take it all the way out and bleed it off? Or just
No. Yeah, just crack it open, a quarter of a turn, and you'll be getting either water or air.
Then we don't supposed to see that valve open in any time in normal operation.
That is correct, yeah. It should be closed in normal operation.
This one can open because the pressure.
Right.
This is when they plant water.
Yeah.
Right here.
And the demand is when it's going to control that pressure.
Yeah, this valve should only open if there's a something happens where we close a valve downstream in the system abruptly. It'll be here to make sure that we do not see excess of high pressure in the discharge manifold in the pump station here. Any other questions? I mean, if they're not going to service the product,
Yeah.
It's pretty bad. Yeah.
I wish I don't know what the dimensions are, but this is like a 4-inch steel down to a 16-inch throat.